Free fall and circular motion. So now we are talking about free fall. What is it? What keeps a satellite in orbit? Let's go to my daily planet diary. My planet diary, finding yourself. Have you ever heard of a GPS? It's a global positioning system. It's a constellation of satellites that orbit 10,600 miles above Earth. The GPS makes it possible for people with ground receivers to pinpoint their geographic location. So it can just tell you exactly where you're at. The first GPS satellites were placed in orbit in 1978. These early satellites were expected to operate for approximately 5 years. Newer satellites have an expected lifespan of 7 to 8 years. Looking at the different satellites, here's a graph, number of GPS satellites launched. So for looks like every 4 years is what the breakdown is. Anywhere 6, 4, 17, 12, 5, and 11. Number of orbiting GPS satellites, so you can see how it's increased. Let's look at the statistics using a graph. Use the data in the table to answer the questions below. Correct. It's a table, it's not a graph. So what is the total number of satellites launched from 1978 to 2007? You might have to do a little math on that. How many were still operating as of 2007? Okay, write your answer here. How many satellites stopped operating between 2003 and 2007? So think about that. What kind of math? How would you set that up if you want to know how many satellites stopped operating between 2003 and 2007? Some of the terminology for this section will be free fall, satellite, and centripetal force. What is free fall? When the only force acting on an object is gravity, the object is said to be in free fall. The force of gravity causes an object to accelerate. Free fall, here's a key concept, is motion where the acceleration is caused by gravity. When something falls on Earth, there is fluid friction from the air around it. The friction acts against gravity, reducing the acceleration of falling objects, and air friction increases an object as objects fall. If an object falls for long enough, the increased air friction will reduce its acceleration to 0. The object will continue to fall, but it will fall at a constant velocity. So what that means is once a ball starts to fall, it's going to fall to a certain speed, and then it will just continue to stay at that speed. So near the surface of the Earth, the acceleration due to gravity is 9.8 meters per second squared. If there is no air friction, a falling object would have a velocity of 9.8 meters per second squared after 1 second, 19.6 meters per second after 2 seconds. Since air friction reduces the acceleration, an object on Earth for 1 second will actually have a velocity that is less than 9.8 meters per second. Look at this photo. It shows a tennis ball and a crumpled piece of paper of different masses as they fall during a friction of a second. If the only force acting on them were gravity, they would fall at exactly the same rate and line up perfectly. However, because of air friction being present, air friction has a greater effect on the paper's acceleration than on the tennis ball's acceleration. This causes the tennis ball to fall faster. Okay, then suppose you had a chamber with no air, eliminating the force of air friction. Complete the table below for an object that is dropped from rest. Remember, the formula for velocity is acceleration times the time. The acceleration due to gravity is meters per second. So here you have it at 0, and then there's your acceleration, figure out each time in seconds up to 4. Go ahead and answer that question. Now I get it. Now I know that free fall is, and go ahead and answer that question.